We are starting chapter 1 notes. So you're going to use your vocab that you have. You can copy your vocab or you can copy the vocab that I'm going to display, but we definitely need to go over vocab as we go along. And then your vocabulary that you have on y'all's shared document, that'll be useful throughout the whole semester. So we're just going to keep on adding to it. So data consists of information coming from observations, counts, measurement, and responses. The term data is plural, so it's correct to say data are, not data is. So if you wrote something different for data on your vocab, you can write exactly what you already have written. It's fine with me. Statistics is the science of collecting, organizing, analyzing, and interpret data in order to make decisions. And drawing conclusions is another aspect of that. Make decisions, comma, draw conclusions. I guess I could put and draw conclusions in order to make decisions or draw conclusions. Population is a collection of all outcomes, responses, measurements, or counts that are of interest. So population is all. So we could look at the population of the students at Chapel Hill or the students at Chapel Hill High School. That would be the population. And then a sample is a subset or part of the population. So if our population is Chapel Hill High School, a sample could be females. That's a subset of the population. Or athletes. That could be a sample. Or you could do a random sample, completely random, by drawing names. Okay. Listed are 3 populations from which data could be obtained. So it's giving us populations, okay? One potential subset from which a sample data would be obtained is listed. List 2 other samples from which data could be obtained. So we have high school students. The sample could be members of the Key Club. There are different things you can write here. So what do y'all think a sample could be? So I was mentioning those things a minute ago. So if our population is high school students, what could be a sample? Yep. What else? What's another sample of the high school students?
Athletes.
Yeah. We're going to take a sample of the athletes, from the athletes. Okay, let's say we have a population of just looking at our nationwide voters. So one subsection or sample would be voters in the 35 to 45 age bracket. How else could we break down nationwide voters to get a certain sample? What's a subset of nationwide voters? Ooh, that's a good one. First time voters. So if we were doing a survey of the first time voters, here's what we found. What's another sample that we could come up with from voters in the United States?
Republican voters.
Yep. Professional athletes. So our population is going to be all professional athletes. So one subsection or sample is a WNBA rookies. What could be another sample? It's represented within professional athletes. How can we break down professional athletes into different samples? What do y'all think?
Like the All-Stars.
All stars from what?
NBA.
Okay. What else? Give me one more.
Male athletes.
Male athletes. Yep. Okay. Let's go to the next page. Parameter is the next vocab. It is a numerical description of the population characteristics. So parameter goes with population. Those are important. That's an important keyword for you. And this word is actually in 1.2. Statistic is a numerical description of the sample characteristic. So parameter and statistic are both in 1.2. Just put 1.2. Okay. Study tip: to remember the terms parameter and statistic, try using the mnemonic device of matching the first letter in population parameter and the first letters in sample statistic. So sample statistic, SS. Population parameter, PP. Hope you remember those. Example: determine whether the numerical value describes a population parameter or a sample statistic. The average salary for an MLB player is 2,645,442. Population parameter implies all baseball players. So this is a population parameter because it says average salary of a baseball player. So this is a parameter. Next one. In a random check of a sample of Pennsylvania restaurants, 29 of the 65 surveyed have been cited with a violation in the last year. Do you think this is a parameter or a statistic? Statistic, because it is a random check. So did they check all of them? Nope. So it's a sample statistic. The keyword would be random check of a sample. So I guess samples actually are keyword there. The next one, a survey showed that of all 311 males at a local school district, 126 were involved in an interscholastic sport, like UL. What would that one be? Statistic or parameter? What do y'all think? Statistic. What's the key word on this one? Huh? Survey. But it says of all. So is it statistic? The key word here is all. So what is this? Population parameter. Descriptive statistics. Where is that in y'all's textbook? Let's see. Because it doesn't look like these notes are necessarily in the right order. Is it descriptive statistics?
Didn't get that at all.
Didn't get that at all? Okay. Nope. What about inferential? Inferential statistics isn't even listed till 141. So these notes aren't exactly matching with our textbook, but that's okay. So descriptive is a branch of statistics that involves organization, summarization, display of data. So it's describing statistics. Describing is the keyword. And inferential means drawing conclusions. So inferential is all about drawing conclusions. Descriptive is all about just describing the data. Example, in a recent study, it was found that 86% of high school freshmen and sophomores slept at least 7 hours per night, and that 61% of high school juniors and seniors slept at least 7 hours per night. So we have the two different percentages. So identify the descriptive branch of this statement. Will this be describing or drawing conclusions? It's describing the data. Let's just underline the descriptive branch of this statement. 86% of high school freshmen and sophomores slept at least 7 hours per night, and 61% of high school juniors and seniors slept at least 7 hours per night. So that would be your descriptive branch. You can put on here underlined above. What inferences can be drawn using inferential statistics? What kind of conclusion could we draw from this? Is there a big difference in freshman and sophomore versus junior, senior? Going from 86 freshmen and sophomore to 61 juniors and seniors. So what kind of conclusion could you draw?
Younger kids get more sleep.
Younger kids get more sleep. Okay. What do you think that would cause that? Less stress. So freshmen and sophomores aren't dealing with as much stress, so they're sleeping more. What do juniors and seniors usually have more of or do more of? Schoolwork, yeah. And then what else? What happens around junior, senior year? They're around 17, 18, so what are they getting? Jobs, yeah. So maybe the high school juniors and seniors might be getting jobs. So they're not sleeping as much. So possible inference would be that underclassmen sleep more than upperclassmen, and then we talked about some others. Okay, there are some things missing from our notes for 1.1. So I'm going to look at the textbook because looking at the textbook will help you as you are going through your assignment. So I do want to highlight a few things in here. So if you go to 1.1, we didn't talk much about sampling. Or, well, prepare, source of data, sampling. So I would look at this chart. So in order to do statistics, you would need to prepare. Context, what do the data represent? What is the goal of the study? Where is the source coming from? And what kind of sample are they using? And then you're going to analyze it by looking at a graph or creating a graph, exploring the data, applying statistical methods, and then you're going to do some type of conclusion. Is it significant? So our first few chapters are all about preparing. And then we'll start graphing and then looking at data and then using our calculator or our computer to actually analyze and apply statistical methods. Definition of voluntary response sample. You already have that written in your vocab. The respondents themselves decide whether to be included. And it gives some examples of what those are. Statistical significance is achieved in a study when we get a result that is very unlikely to occur by chance. So having 98 girls and 100 random births, it's statistically significant. Because how common is it if there were 100 babies being born, and 98 of them are girls. Is that very likely? So if you get 98 girls and 100 random births, it's statistically significant. But if you get 52 out of 100, because you would normally expect 50 out of 100, half. So 52 out of 100 is not statistically significant because could easily occur with random chance, 50-50 chance. Okay, different pitfalls of analyzing data, misleading conclusions. We were watching the news, I think it was Saturday, and I thought about recording it for y'all, but it was basically saying there was a poll done to see how many people wanted Trump out of the office immediately. And it came up with a really high number. And what this news station was showing is that it wasn't a random sample, that 30-something% were Republican that were asked this question. That means 70% were Democrat, were asked the same question. So that seems like they're asking a larger portion of Democrats, which you would expect the answer to be yes. So it turned out to be a bad survey, but of course, that other news station didn't say that. They just said, these people, a huge percentage, want Trump out of the office immediately. They didn't give you who they surveyed, where they came from, was it a random survey or not. So you got to be careful of that. You got to pay attention to where the information is coming from. Sample data reported instead of measured. So you'll need to read through that. Loaded questions. This one's a big one. It's being careful of how you word your survey. I was given a survey one year about I guess I can't really say, but it was a survey here on campus, and there were loaded questions on there. And those loaded questions made a lot of people feel like they were bad for saying yes or no. It wasn't a fair question. It was just, it makes you feel really bad. If the question makes you feel bad, it might be because of the way it was worded. So should the president have the line item veto to eliminate waste? Well, that's talking directly about eliminating waste whenever this says, should the president have the line item veto or not? It's not leading you about one thing or another. This is about eliminating waste, which if he doesn't eliminate waste, then he's bad, right? So it's all about those leading questions. You got to be careful with those. Order of questions is important. If someone refuses to respond to the survey question, or maybe they only respond to one or two, you got to be careful with that. All right, percentages, just a little information on how to convert percentages to numbers. So 6% of 1,200, you can multiply 0.6 times 0.06 times 1,200, or multiply 6 out of 100 times 1,200. So these are things that y'all probably remember, but don't forget to move your decimal if you're doing 6%, or just convert it to a fraction, either way. Decimal to percent, remembering how to do that. Fraction to percent, and then percentage to decimal. So remembering all of those. So we are done with 1.1. So you're going to go through and get on My Math Lab now.